So properties from algebra is our topic. Like I said before, these properties can be used to prove things in geometry. So we're going to review some of these. The first property that I want to talk about is, so write this down. Hold on, let me move this up. Give me a second. So these are properties of equality. So they're called some property of equality. So first one is called the addition property. It just looks like the name of this property is addition property, but like I said, it's called addition property of what? Equality. Okay, so these are properties of equality. So you already know this one. Do you guys remember, like, if I have an equation, can we add both sides by the same number? Yeah, that's how we solve things, right? Because when you add both sides by the same number, it doesn't change the solution, right? It doesn't change the outcome, right? So that's how we could solve for x and things like that. So this property says if a is equal to b and you got a c, what can you tell me about this property of equality? Yes, sir.
Wait.
A plus C equals to B plus C. That's how we learned it in algebra. Now they add this here. Not just C, but they say, and C is equal to D. How would you change that then? Instead of saying A plus C equals to B plus C, now if C equals D, what can we say? Yes, sir?
A plus C equals B plus D.
Exactly right. So that's what the addition property of equality says. If A is equal to B and C equals to D, A plus C equals to B plus D. Okay? Because C is equal to D, right? After all, they're saying the same thing really, but they added that part. So in algebra we just have C. Okay, if I have addition property of equality, could we subtract both sides by the same number? Does that change the answer or the solution of an equation? No. So guess what we're gonna have next? Subtraction property of equality is exactly right. So I got A is equal to B and C equals to D. Okay. Anybody want to guess what it's going to say? Yes, sir.
If A equals B and C equals D, then
A minus C equals to B minus D is exactly right. And of course, we could also have multiplication property of equality. Right? If you could have addition property, can we multiply both sides by the same number?
Yes.
Yeah, it doesn't change the solution, does it? Outcome, the solution. So if A is equal to B and you got C, can somebody tell me what to write? Then what?
C equals A.
Raise your hand. Someone else, come on, same people. Yeah, exactly. A times C equals to B times C. They wrote it this way. Is that okay? C times A equals to C times B. They're the same, right? They're equivalent. Oh, you guys? No, I don't have C equals to D in this case. I just have C. So, and I don't even write the C. So, but you know what I mean. Huh? Yeah, I don't have one for them. So, what property tells you that CA is same as really AC? You guys remember this one? Tony? Commutative property of multiplication is correct. Does that make sense?
Wait, where does C come from?
Yeah, it's just some other number. See, don't worry about it. Are we okay?
Yeah.
All right. Next, we have. Anybody want to guess what we're gonna have? Yeah. Division property of equality. Don't just call it division property, then you're gonna get it wrong. Okay, these are property of equalities. Okay, so if A is equal to B, and you have C, can somebody tell me what we could write? Yes, sir.
A over C equals B over C.
A over C equals to B over C, and you'll be almost right. You got to be careful in terms of C. Can you think of what C can't be? C can't be what? Since you're dividing?
Zero.
Exactly right. So whenever you divide, you have to be careful, right? So see, they're being careful here. Yeah, A over C equals to B over C. That's right. Okay, but you got to just make sure that C isn't zero, right? So it's something we already know. We just have to say it. Otherwise, some people say, well, what if C is zero, right? Then it doesn't hold. Okay. If A is equal to B, what can you say? Like, you could replace A with then B. That's what substitution property is. This is how they say it. Then either A or B may be substituted for other in any equations or inequality. Okay, so you may substitute two expressions that have the same what? Yeah, value. Yeah, if they have the same value, then you could substitute that in, and then it will not change the outcome. Okay. Very good. Okay, let me wait. People are still writing. Now, we're going to go back to properties of equalities again, okay? So it's kind of interesting they actually put one in the middle where it isn't property of equality. But anyway, this one is the one when you learn in algebra, you say, why do they even have this one? Because it's so obvious. It's called some property of equality. It's a, yes, sir, what do you think? Reflect, what do you think it says? You're right. This next one is the reflex. What? Say it again? Yeah, what does it say? A is equal to A is exactly right. And you go, what's the, isn't this obvious? A is equal to A, right? Oh, I'm sorry. Here you are. Okay. So reflexive property.
So these are no properties of equality. It is. This one is.
Thank you.
Oh,
Yeah. Everything except for that substitution was property of equality. Okay, so exactly. I don't know. If the book puts it that way, I don't know why I did. Okay, so this one, some people have trouble remembering. So like the way I do this is I say, okay, in a mirror, when you reflect something on a mirror, you get the same exact thing on the other side, right? So think about reflection of a mirror, but don't call it reflection property. It's called the reflexive. It's not reflective property. It's reflexive. Okay. So anyway, the next one.
Wait, that's it?
Yeah, that's it. This one is a very interesting property because it's so obvious, right? You wonder why did they even mention this? You learned why today because it turns out when you're proving things, when you include some of these reflexive property, it actually helps the readers to follow the proof a lot easier. So I'm going to do an example today, see if it could catch up. I mean, you could catch that part. All right, so next, are we ready? The next one, these properties come by, there are three of them like this. Reflexive property of equality. The other one was called, symmetric property of equality. Who remembers? Okay, a lot of you remember the name. Who remembers what this says? Okay, so by the way, what does things that are symmetrical, what does that mean? Things that are symmetrical. Yeah, they're like, not the same, but yeah, these are of the equality. Yeah? Well, what sort of things are symmetrical? Yeah.
Circle.
Circle is symmetrical, very good.
Square.
What? Butterfly, sure. A square, sure. What about in terms of numbers? Like number 3. Is number 3 symmetrical?
No.
It kind of is if you were to cut it horizontally.
8.
How about 8? Yeah, 8 is a nice one. What about 0? Okay.
1.
Okay, so. Okay, very good.
11.
Hello? Okay, good. Okay, let's move on. Okay. What about 9? Is 9? No. Okay. So then anybody know why we call this symmetric property and what does it say? And who remembers what this one said? Yes, sir. Justin? Exactly right. And why do you think they call this as symmetric property? Yes, it's sort of symmetrical, isn't it? If you were to put a line through right here in the middle, here's A, B, and then BA. You see what I mean?
Then would not be.
Yeah, if part won't be. Oh, you're right. Okay. Yeah, and then some of you say, well, it's not really mirror image, right? I know, like that, but you get the idea. What's the last? It starts with T. Yes. Transitive property.
Oh, I know.
Transitive property of equality. Oops. You can't. Okay, so. Yeah, you remember? One person remembers what this says?
Oh, I remember.
How about somebody that I haven't called? How about Young? Huh? Yeah, it has if and then part, but that's not that's not the whole thing. Okay, well, that's good. John, what do you think?
If A equals B and B equals C, then A equals C.
Exactly right. If A is equal to B and B is equal to C, you guys remember this? Since both of them are equal to B, right? A and C, they're both equal to. So what can you tell me about? Since A and C are both equal to B, what can you tell me about A and C? A equals. That's the conclusion you can make. Then A is equal to C. You guys remember that? Yeah, these are all properties of equality. So far, only thing that wasn't property of equality was the substitution. All the other ones were properties of equality. Okay? Very good. Okay? May I move on? It turns out though, guys, these last 3 properties, you could replace them with, these are all properties of equality, right? But these last 3 ones, you could actually use them with properties of congruence. Do you guys remember like when 2 things are congruent? Like for example, when 2 segments are congruent, what's that mean? They both have the same measurement. When 2 angles are congruent, they have the same Angle measure. So same idea, you could actually use not only for equal sign, you could actually use for congruent symbol. So you could also have reflexive property of, instead of equal sign, you could, instead of, it's called congruence. Does that make sense? So let me go over, so it's for these three of these, the last properties. Okay, let me go on to that. So here are now properties of congruence. And as I mentioned before, you may have reflexive property of congruence, okay? So,
Wait, so
Eamon, what do you think? Eamon, what do you think about this reflexive property of congruence? I could have DE congruent to what? Not ED. Remember, it was A equals to A, so it's exactly the same thing. Segment D is congruent to segment DE again, exactly. So when you want to say, right, that the the same segment is congruent to itself, we will call this reflexive property of equality or reflexive property of congruence. Congruence. You see that? Okay. What about for an angle, like angle D, for example? Angle D is congruent to then angle also D. That's called the reflexive property of congruence. Okay. Don't use equality there, right? Now that we're using congruence. And guess what? The next one is, of course, what's the next one going to be, guys?
Oh, symmetrical.
Yeah, not symmetrical. Symmetric property of congruence. So as you can see, if DE is congruent to FG, who could tell me the next part? Then, who could tell me the then part? How about, oh, you're still writing? I'll wait. Okay, go ahead and write down the then part. Okay, what would you think for this one? Eric, what do you think? If DE, right here, if segment D is congruent to segment FG, what would symmetric property say? Then what? Yeah, not equals to, congruent to. Yeah. So segment FG will be congruent to segment D is exactly right. And could we do this for an angle? If angle D is congruent to angle E, who could tell me then, what can we say here? How about Naomi? What do you think we should say? Using symmetric property of congruence? Exactly right. Then angle E is congruent to angle D. Okay? And of course, the last one, transitive property of congruence. As you may expect it, if segment DE is congruent to segment FG and segment FG is congruent to segment JK, what can we conclude here? Jonathan?
Segment DE is congruent to segment JK.
You got it. Is this what you expected? And of course, you all fill out the last part for the angle then. What do you think? If I have these angles congruent, if angle D is congruent to angle E and angle E is congruent to angle F, go ahead. You guys finish it up. I'll wait. Okay, so who could tell me what to write here? I would like to ask Hannah. What do you think? What do we?
Then angle D is congruent to
Exactly right. Okay. Does that make sense? So there are some other properties that we haven't talked about, but there's a property that starts with D in algebra that we use a lot. Anybody remember what that one's called?
Property of these.
No, the property that starts with D, letter D, that we used in algebra a lot. Yeah, it's what you're thinking of. It's not. Yeah, distributed property. Okay, so that's. Yeah, see, I told you. You should just. So you guys remember distributed property, and this is not like property of equality or congruence. Okay, it's just called distributed property. And remember what distributed property says? You know, if A times B plus C, if you have this, then you get A B equals to AC. You guys remember this? So it turns out we could use all these properties that we learned in algebra to sort of justify steps. Okay, so here's what I mean by that. Let's do an example. Don't write this down. So we could use the properties that we learned in algebra to justify each step. So you guys remember doing something like this? They say solve this. Of course, we all know how to solve this simple equation, but do you know how to justify each step using all the properties that we learned in algebra? Yes. So for example, you do, okay, let's see. First, they give you this. What's the reason I could write that? Yes? Yeah, very good. You all know that one. Given, okay? No. I said just follow along, okay? Next, they say given equation, but you could just write given. Okay, next, they give you this. What can you write, or how can you justify this step so that this is still true about this equation? In other words, how do I go from step 1 to 2, and this is still correct. What do they do? What property do they use here? Raise your hand, raise your hand. How about Nicole?
Wait,
Distributed property?
oh wait, no, proper, no wait. I know what they did proper.
What do they do? Show me. Tell me. Okay, guys, put your hands down. Yeah. What do they do?
By two.
They multiply both sides by 2. So when you multiply the same number by, when you multiply a number to both sides of an equation, what is that called?
Oh, multiplication property.
That's right. Very good. It's called. So because of multiplication property of equality, we could go from first step to second, right? Without changing any of the solution. Correct?
More like that way, so it covers.
Like this?
Yeah, it was very.
Oh, okay. Okay. All right. Esther Yoon, what do you think? So they go from here to here. What do they do here, Esther? Addition property of? Exactly. What did they add both sides by? X, exactly right. And now, of course, what can we do here? Grace, we could both. Yeah, we could divide both sides by 7 because of the division property of equality. You see, do you guys remember doing something like this in your algebra class? Turns out, by the way, and I was also, is this the only way to solve equations? No. You could. Somebody said, well, you could actually, add both sides by half x and so forth, right? So as long as you do them correctly. By the way, what sort of logic are we using? What sort of reasoning?
Deductive.
Deductive reasoning. Okay. We are using, very good. We are using, class, logical, right, reasoning, right, to prove these. So we're using deductive reasoning. Okay, now, so we could actually, just like equations, there are many ways of solving equations. Same way for proofs. And you will see that it's very similar to doing something like this for a proof. Instead of them giving you an equation and asking you to solve, they're going to give you a statement, a given statement, and they're going to give you a statement that you want to get to. In other words, that's the statement that you wanted to prove. So let me get you, here's our first ever proof. You don't have to write this down, it's on your book. But what I want you to mainly see is how they go about doing this thing, okay? So let's take a look at it. Here's our first proof. Here's a given statement, guys. It says, no, I want you to just take a look at it, like I said before. I'll tell you what to write in a minute, okay? So it says RT, the segment, and segment PQ intersecting at S, so that RS is equal to PS and ST equals to SQ. By the way, what does it mean if you just have RS without the segment symbol on top? Yeah, the distance of that segment or the length of that segment, right? And here they want you to prove that RT is equal to PQ. Now, what's important here is really understand what they mean by this given statement. So I want you to draw, because many times you will see that lots of time they won't give you any drawing. I want you to draw on that piece of paper. You don't have to write this down, but draw what they're describing right up here in terms of given, and think about what is it that they want you to prove. Go ahead, I'll give you time. And you could talk with your group members, that's fine. Go ahead, I'll give you time. As I went around and looked at your picture, very interesting, guys. Listen, first of all, we don't have any lines, do we? We have line segments. So is it okay to draw lines with arrows? No. So we need segments. We need endpoints, okay? Secondly, let me ask you this. Guys, let me ask you this. Should these two line segments intersect in a way that they're 90 degrees? I saw a lot of you had two of these lines. I mean, you didn't put that little mark, but they look like they're 90, right? But they don't have to, so please keep that in mind. None of the right, given statement says they have to be perpendicular, right, when they're intersecting. Can they? Yeah, sure. But do they have to be? No. So do you think it's a good idea to draw them as 90? Yeah, I think it's a good idea because sometimes if you draw them as sort of 90 degrees, you may assume, right, even though you didn't mean it, you may think they're 90 or something like that. Okay. Secondly, a lot of you drew the picture correctly, but did not put this information in the drawing. RS equal to PS. ST equal to SQ. How can you put that in the drawing? 1, 2, 3. Some of you actually did it. I saw it, but some of you didn't. Okay, how about, what can we do? Yes, sir, Nicholas, what do you think?
What I did was I drew the
Tick marks. Very good. So, by the way, guys, do you think using those tick marks to indicate that two segments are congruent, do you think that's important? Yeah, it's going to be actually really important to prove this thing, right? So the reason why I did that, guys, is because if we're not on the same page as what this is talking about, if we misunderstand, right, this given information, do you think it's possible to maybe prove it wrong?
Yes.
Yeah. Okay. So a lot of you had this picture, and this is what they're describing. You have two segments, okay? And I'm sorry. Here you go. You have two segments here, and as you can see, by the way, it could be rotated in any angles you like. Okay, it doesn't matter. It doesn't have to have R up here and then P up here. You know, but you have to have RT the segment. You have to have the segment PQ, and then S, of course, is intersection. And look, RS. You see, you have a tick mark here. RS congruent to equal to SP, and then SQ equal to ST. Does that make sense? Okay. By the way, is it important to note that these have two tick marks, whereas these have one? Yeah. What if you just put one tick marks on all of them? That means all four segments are congruent, right? Which is wrong. That's not what they're necessarily saying. It could be, but that's not what it doesn't have to be, right? So please be careful. Now, before we do any proofs, guys, it is really important, okay, to sort of know which way we should go. Okay. So in other words, without really proving it, does this make sense? Does the thing that we want to prove, that RT equal to PQ, does it make sense that it should be equal to, in other words, this whole segment, you know, this whole RT, does it make sense that this whole segment should equal to this segment PQ? Yeah, why? Somebody explain just in words. Yeah. If your little brother or somebody, right, ask, okay, why should that be equal to, what would you say? Does it make sense to, yeah, what would you say?
Because like it's the same. Like,
Right, okay, little bit more than that.
oh,
Yeah, okay, go ahead.
It's the same measurement.
Yeah, what has the same measurement?
The line.
The line. Okay, so sometimes it's helpful to actually use some numbers. Yeah, what do you think?
The both lines are made up of the same one part, one mark and two. So like they have to be
Exactly. You could say, like, look, if RS, since it has one tick mark, let's call it has 1 unit, right? If this is 1 meters or something, and this is 1 meter, and let's call this 2 meters, 2 meters, what's the whole thing? 3. Of course, this whole thing is 3, then this whole thing is 3, right? It makes sense that that's not how you prove it, but you could kind of, right, intuitively see that they're going to be same length. That's how you're going to actually prove it too, actually. Does that make sense? So let's go through our first proof. First, okay, 90% of the time, you always start with given. So which given? There are a whole bunch of them. You don't have to write this down. It's in your book. I just want you to follow along, and I want you to understand. That's the important part. So, because I don't want... Okay, so first given. There are a whole bunch of stuff in the given part. Which one should I use, you think? I think, yeah, the second line. Because first one is sort of kind of explains the picture, right? That's where they intersect. But here, right? Wouldn't you say that first? RS is equal to PS, the length of these two segments. And ST, of course, equals SQ. So, of course, the reason is, of course, is because given. They gave it to us. Okay. What is that we want to do here? From this given statement, we want to get to what? Yeah, the proof, the last statement. RT equals to PQ. All right? So, and think about what we did in terms of trying to understand why should that be true. What do you think we should do next? Okay, I want you to think with your group. Go ahead. Think about as a group. What do you think we're going to do next year? How are we going to get to RT equals to PQ? Any idea? Let me give you a hint, guys. Turns out it's one of the properties that we learned today in class. So one of those properties that we learned in class, we're going to be using this right now. Go ahead, think about it. That's the hint. Hey guys, I'm glad you guys are really thinking through. And is proof easy? No, in the beginning it's not that easy. You have to actually, just like remember factoring? Was factoring really easy in the very beginning? No. But as you do more, was it? Okay. For some of you it was. But you got to try many different ways, right? Hold on. Okay, hold on. Shh. Okay. So does that make sense? Guys, listen. Proofs the same way. You have to actually try all this different sort of method. And the person actually proved this thing, it didn't come to him naturally, like right in that second. They had to actually think through, right? So guess what? The next one, and I said it was one of the property that we learned, they actually used addition property of equality. Because you could think of this as A is equal to B and what? C equals to D. So you could get this. And there's a reason why they have this statement as a second statement. How many people see how this will be helpful for us? Look, okay, you could think of RS as A. Okay, a lot of you think, okay, thank you. You could think of RS as A and PS as B, right? And then ST as C, SQ as D, right? And of course, A equals to B, then C equals to, and C equals to D. Then what can you say about A plus C is equal to what? B plus D. Why is this helpful? And isn't this what we did with if this was 1 meter, this is 2 meters? If this is 1 meter, this is 2 meters. Isn't this whole thing 3 meters and so forth? How is this helpful for us? Yes?
Because we know that now we can use the second addition postulate.
Right?
Um,
Exactly. Now, we could use, Justin says, we could use segment addition postulate. What does it say? RS plus ST is equal to what, guys? Isn't it RT? And isn't it what we want to kind of get to? RT?
Yes.
And what do you know about PS plus SQ? PQ, right? And isn't it because of we just said a segment addition postulate? By the way, could you have written this underneath so that it will be step 4 as PS plus SQ equals to PQ, and then write this twice? Yeah, but why would you, right? If they're the same thing, okay? So it's a safe step, okay? You know, because the reason is same, right? If the reasoning is same, you don't have to separate them. You could put them together. Question? Okay, I'll give you time. Now I want you to discuss with your group. Very good. And then think about how we could finish this. And Yechan, I want you to ask your group how they get the second step. Go ahead, I'll give you time. Then next step that we could take is, turns out, we could actually go straight to now, RT equals to PQ. What allows us to do this? Yechan? Substitution, exactly right. Do they have the same value? The RT has same value of what? RS plus ST. PQ has same value of PS plus. So look at what it says in the second step, right? We said RS plus ST equals to PS plus SQ. Well, what's RS plus ST? RT, we just said that, right? What is PS plus SQ? PQ. Now you're substituting it in. Does that make sense? So when you use substitution method, it's right. It's for like numerical values, right? Aren't these numerical values? These are some number, aren't they? Because these are the length of the segment. Does this make sense? Do you see how we use deductive reasoning to go from the given statement to the statement that we wanted to prove? Okay, this is our first ever proof. Any question? Can you do something like this for your homework tonight? Yes, you can. Okay, so you gotta try it though. It doesn't.
14 of
It,
those probably.
no, not all of them are like this. Okay, some of them are. Okay, are you okay? Does that make sense? All right, let me move on to the next one. Again, let's try now. You don't have to write this down. Actually, let's do this. I'm gonna help you do this yourself. I'm gonna give you time. Take a look at this example 3. Before I do it though, I'm going to help you a little bit, okay? So take a look at it. Now, whenever you have a proof, it's always a good idea to see if this makes sense to you, right? Then look at this angle. This time they give you a picture. Look at angle AOC. They're saying this angle AOC, right, is equal. The measurement of AOC is equal to measurement of angle BOD. Okay, that's fine. Now, they're saying that if that's true, and this is what these angles look like, measurement angle 1 must equal to measurement angle 3. Okay? Do you think this should be true? Yes. Why, Brianna? Okay, you need to put those down. You got to pay attention here. Why do you think angle 1 and 3 should be congruent if you have this set up? Because we have to actually understand, right? It has to make sense to us, first of all. And you should be able to, it'd be great if you could actually explain why this should be true. Because that's the way you're going to actually be proving this, just like before. You remember with that segments? Remember if we add those two segments, it became 3 meters and so forth? You could actually use like angle measure too if you want, but how would you explain? Not quite sure? Okay, go ahead. I want to think, go ahead, think about it as a group. I'll give you time. Why should 1 and 3 be congruent? You could actually use some numbers too, okay? Even though that's not really proving it, it helps us understand it, okay? Okay? A lot of you have great ideas. Okay, let me ask you this. Hold on. By the way, would anybody want to share why they think angle 1 and 3 should be congruent? Just explain it. It's not a proof, but yeah, what would you?
Since AOC equals BOD, then
Right?
AOB plus
Right, that's why they give you actually this angle. They have these angles have 1 to 3. So what you're saying is basically, is an AOC made up of angle 1 plus 2? Is an angle BOD made up of angle 2 plus 3? Well, aren't they sharing the same angle in the middle? Yeah, if you take out that same one, yeah, then don't you have angle 1 equal to angle 3? No, so for example, look, if AOC was like 60 degrees, okay, and angle BOD was also then 60, right? Let's say the angle 2 is like 20 degrees. What's this one? 40. What's this one? 40, because they share the same angle. Is that right? That's the reason. So that should kind of guide you in terms of how to prove this. Now what you have to do is then actually use that sort of step to prove. So let's do that one. Okay. Well, I was gonna actually have you do it by yourself, but no. Okay, just take a look at it because of time. We'll just and it'll be recorded, right? So here, first you're gonna say, let me give you the first one. Oh wait, we do have time. Okay, go ahead. Why don't you try yourself? I'll give you some time. Just do as much as you can.
Do we have to write it?
Yeah, write this down. Go ahead. Do as much as you can. So the second step will be just like we said. Look at what's angle AOC is made up of. Isn't that made up of angle 1 and angle 2?
Yes.
So I'm going to say this. And what tells us,
Subtraction.
raise your hand, what tells us that you could write this? Jason.
Angle addition.
That's right. It's because of the angle addition postulate, right? Okay, like I said, do you have to follow exactly this way? No. But the way they give you in the book is the simplest way. So follow along and see if you understand. Okay, that's fine. Here, next, if this is true, I'm going to say, wait, didn't we just say AOC is congruent to BOD? Many times, though, people just have this in their head and they don't actually say this. So guess what? This is a step that people forget to write. They don't write this. They just have this, because we said first one, the second statement, people don't state this and get it wrong. Isn't this something that we have to state? Even though in our head we know, okay, we can actually see, right? That angle 1 plus angle 2 is same as angle 2 plus angle 3, but you have to say it. Okay, this is a very a mistake. This is a mistake that I see often. People see this, they have this in their head, therefore they don't write it out. If you do that, guess what? Get it wrong. And what's the reason why? Substitution. We're basically substituting in again. Now, isn't this nice? Look, angle 1 is over here. Angle 3 is over here. Look, they have the same two angles. Can we just subtract those from both? Now, here's reason. Okay, before I do that, I'm sorry? Yeah. From the first step to second. Now, look. Now, we could subtract both sides by? But hold on. Before we do that, measurement angle 2. But before we do that, look what they do. Did you have a question? Oh, look, I'm going to do this. That angle 2 is same as angle 2. Do you see why this, by the way, this is called the? Do you see why this is helpful? Because it's telling the reader, okay, look, I know that these two angles are same, and I know it's obvious, but why am I saying this right now? Because I'm about to subtract what from both sides? Angle 2, that same angle. So when I do this, what do I get, guys? Angle 1 is measure angle, exactly what we wanted. What's the reason? Raise your hand. What's the reason? Yes.
Subtraction property.
Thank you. We get subtraction property. By the way, they didn't put something here. They forgot to put something. Anybody see what they forgot to put? Raise your hand. Raise your hand. Yes, sir. Where? On the?
Number 3 and 4.
No, substitution is just substitution. The fourth one, you need to write down reflexive property of equality. They forgot to put that thing. Okay,
So
but
it's a typo?
yeah. Okay, so do you see why we need reflexive property here?
Yeah.
It's because
To make sure.
who would like to explain? Listen, some of you don't get this. Why do we need to put the reflexive property here in the middle? What's that? Who could explain to? Who have an idea? Yes, sir. Yeah, what are you subtracting from both sides here, Yachan? And don't they have to be the same one that they're subtracting from both sides? You have to state that, yeah, we know since they're the same angles, we could, yeah, you have to tell the reader, I'll be subtracting angle 2 from both sides, and of course angle 2 is equal to itself. They have the same measurement. So you're subtracting the same number from both sides. It makes it a lot more concrete.
So you
Yeah, yeah. Well, if you're gonna do that, you'll see that this is kind of nice.
Does it always have to be like this?
So, well, not I cannot say always, but it's nice to actually, if you're gonna subtract same number from both sides, state that first. Does that make sense? Okay, guys. Hello. Oh, any question? Guys, listen. Okay. Hello. Okay. So, do you think you could do something like this for your homework tonight? Yes. Okay.
Kind of.
Okay. Do your best. Remember, I told you a big jump from algebra to geo is the proof. If you don't get this now, and if you don't try it, guess what? It's going to get harder and harder that much. Okay, so you really have to put your effort into this. Hello, just do as much as you can. Does that make sense? Yeah. All right, good.